Okay, in this example, this is question 9, video H. It's hard to read it up here. I apologize. It's a good thing, hopefully you have a copy of this sitting right in front of you. It says how many joules must be added to a 50-gram block of aluminum to heat it from 22 degrees to 85 degrees Celsius. And we're given the specific heat capacity of aluminum, which we call C, and that is 0.900 joules per 1 gram per Kelvin. Okay, we know delta T here is going to be 85 minus 22, so that's going to be 63 degrees Celsius, and that will be two significant figures. So if that had turned out to be 60 degrees Celsius, we would have needed to somehow show that the zero is significant. Okay, and then we know the mass is 50.0 grams. Now with calorimetry, we have this equation that we use over and over and over again, and that is shown here. Q, which is the heat exchanged, equals mass times delta T times the heat capacity C. So notice here that we're going to have C in there, which has joules over grams and kelvins, and we're going to be multiplying that times delta T, which is in Celsius. Now, if you recall, because we are dealing with a delta T, and because the size of Celsius and Kelvin degrees are the same, you can actually cancel Celsius and Kelvin here. Or you can rewrite this as 63 Kelvin. Because if you were to go up here and change these to kelvins and then subtract them, you would get 63. Okay, and then the mass here is going to be 50 grams, and that's going to cancel the grams in the denominator of C. And we're going to end up with Q having units of joules, which is what we want. So we're asked how many joules must be added. Okay, so we're going to solve for Q. Q equals, I'm going to go ahead and write C first. Okay, so I want to cancel out grams and delta T, so I'm going to multiply by 50 grams and by 63 Kelvin. So here I can cancel out my grams, cancel out my temperature unit, and I'm going to end up with joules. When you do this on a quiz or exam, I'd like to ask you to please clearly show your cancellation of units. So this gives me 2835 joules. Let's see, it doesn't specifically ask me for kilojoules, but I'm going to go ahead and change it to kilojoules, and I'm going to just keep my first two significant figures. So 2835 joules times 1000 joules per kilojoule gives me 2.8 kilojoules of heat energy. So this tells me how much heat you have to apply to an aluminum block to get it to change, get it to be 63 degrees warmer, and given that the block of aluminum has a mass of 50.